Good afternoon, students. So today's topic is linked list. So yesterday we had discussed queue. Now today we'll study linked list. So before understanding the linked list concept, we first look at why there is a need for a linked list. Like we are having one data structure that is array, then why we are in need of another data structure which is linked list. So if we want to store the value in a memory, or if we want to store some data in memory, we need a memory manager that manages the memory for every variable. For example, if you want to create a variable of integer type like integer x. So in the above example, we have created a variable x of type integer. As we know that integer variable occupies 2 bytes, so x variable will occupy 2 bytes to store the value. Now suppose we want to create an array of integer like integer x of 3. So this means that we can store 3 values in the memory. So we have declared an array of size 3. As we know that all the values of an array are stored in a continuous manner, so all the 3 values of an array are stored in a sequential fashion. The total memory space occupied by the array would be 3 into 2, that is 6 bytes. So the problem with the array is there are two major drawbacks of using array. First of all, we cannot insert more than 3 elements in the above example because only 3 spaces are allocated for 3 elements, because we had already declared the size of the array as 3. Now since we had declared the size of the array 3, we can store 3 elements or 3 values only. Now if we want to store some more values, we cannot do that. We have to stop the execution of program, change the size of the array, again we have to compile the program, and then we have to execute it. So this is one drawback. And second is in the case of an array, lots of wastage of memory can occur. So memory is wasted here in array data structure. So we are providing the fixed size at the compile time, due to which wastage of memory occurs. Now for example, beforehand if I had taken size of the array as 50, this means that 50 multiplied by 200 memory locations will be allocated for storing data in array. But at the runtime, I am in need of only 35 variables. Means I am storing only 35 values. So rest of the space for 15 variables which I had created already will be wasted. So that is the problem with array. So the solution to this problem is to use the linked list. Now, what is linked list? So, a linked list is also a collection of elements, but the elements are not stored in a consecutive location. Like in array, whatever data we are storing it in contiguous memories. In linked list, the elements are not stored in a consecutive location. Now, suppose a programmer made a request for storing the integer value, then size of 2 byte memory block is assigned to the integer value. Now the programmer made another request for storing 3 more integer values. Then 3 different memory blocks are assigned to these 3 elements, but the memory blocks are available in a random location. So here the point is, like in array, beforehand we have to decide the size. If the need arises at the execution time, we cannot store that data because we don't have that space. We have not allocated that space. So that is the drawback. But here in linked list, whenever we are in need of memory, we can request for that and we'll get the memory. The only problem here is that the memory locations are random. The memory locations are not contiguous. So how the elements are connected? Because whatever data we are storing, it is in the form of list. But here the memory locations are random. So how the elements are connected? So these elements are linked to each other by providing one additional information along with an element, that is the address of the next element. So here in linked list, in array, we store only values, data, whatever data we are having. But in linked list, we have to store data as well as address of the next element, where exactly that element is stored. So the variable that stores the address of the next element is known as a pointer. Therefore, we conclude that the linked list contains 2 parts. The first one is the data element and the other is the pointer. The pointer variable will also occupy 2 bytes, which is pointing to the next element. So here is the definition for linked list. A linked list can also, it defined as the collection of the nodes in which one node is connected to another node, and node consists of two parts. So here data is stored in a node, and the node consists of two parts. That is, one is the data part and the second one is the address part. Now we can see in the figure, one linked list is shown to us. In that, we are having four nodes. The first node is having data 10, second node is having data 15, then third node 5, and fourth node 20. We are having one pointer which is head, and head is pointing towards the first node. So head is having address 4800. So it is pointing towards the first node which is having value 10. Now in the pointer part, or in the address part of the first node, it is the address of the second location. So the address of the second node is 4900. So the address of the second node is stored in the first node's address part, 4900. It is pointing towards this node. The second node is pointing towards the third node. The address of third node is 5000. So that address is stored here. So that is 5000. Now the second node is pointing towards third node, and third node is pointing towards fourth node, and so on. In this way, the list is linked. That's why it is called as linked list. And whenever the list is going to finish, so the last node address part will have null in it, because it is not pointing to any other node. That's why it will have null in it. So in this way, we can store data in a linked list. Here we can observe that each node contains the data and the address of the next node. The last node of the linked list contains the null value in the address part. So this is the last node. This is the first node which is pointing by head or first pointer, and the last node will have null in its address part. Now, how can we declare the linked list? So we had seen the declaration of array. If we have to declare an array of integer type, so integer x, and in bracket we have to write this, in square bracket we have to write the size of the array. So how declaration of linked list is done? So the declaration of an array is very simple, as it is of single type, but the linked list contains two parts which are of two different types. One is a simple variable and the second one is a pointer variable. So we have to declare both the things. Now we can declare the linked list by using the user defined data type known as structure. Since we are having two different types of data here, we have to store two different types of data. One is a value which can be of integer, character, or float type, and second is address, which will be always of a pointer type, because address, we are going to store address in pointers. So since we have to declare two types of variables here, so we are going to use the user defined data type, which is structure. So we have defined a structure named as a node consisting of two variables, one an integer variable, that is data, and the other one is the pointer next, which contains the address of the next node. So in this way, declaration of array can be, linked list can be done. So here what we had done is we had created one node. Now the advantages of using a linked list over array. So the first advantage is dynamic data structure. So the size of the linked list is not fixed, as it can vary according to a requirement. So memory is allocated at runtime as compared to array. In array, memory is allocated at compile time. So at runtime, if we are in need of extra memory, we cannot get that. But here, the name of the data structure is dynamic data, or it is called as dynamic data structure, because the size of the linked list is not fixed. As per our requirement, we can add nodes in it. The second advantage of linked list is insertion and deletion operations are quite easier as compared to array, because array is consecutive in nature, like nodes are consecutive. So if I want to insert one element in between, so first I have to perform shift operations. wherever, whatever location on which I have to insert the new data or new value. So first I have to create an empty node, empty space there. For that I have to shift the data, and then only insertion is possible. Similar with deletion is there. If I want to delete a node, I have to shift the data. So in array, the insertion and deletion task is tedious, whereas in linked list, insertion and deletion is simple. So we can say that the insertion and deletion in linked list are easier than array, as the elements in an array are stored in a consecutive location. In contrast, in the case of a linked list, the elements are stored in a random location. The complexity for insertion and deletion of elements from the beginning is O of n in O of 1 in the linked list. In case of array, the complexity will be O of n for insertion and deletion. Next advantage is memory efficient. So its memory consumption is efficient, as the size of the linked list can grow or shrink according to our requirements. Because if we are using dynamic memory allocation functions, so there we are having malloc, calloc, free. So this free function is very important. If we want to delete an element, we can leave that memory location also, and we can reuse that memory location. So that memory efficiency is there as compared to array. Next is implementation. So we can implement any data structure using linked list. For example, we can implement stack, we can implement queue, we can implement tree using linked list. Next point is disadvantages of linked list. So the first disadvantage of linked list is memory usage. Here we are in need of extra memory, because apart from data, we are storing addresses also. So for that, extra memory is required. The node in a linked list occupies more memory than array, as each node occupies two types of variables. One is a simple variable and another is a pointer variable. So that is the problem. Next is traversal. In a linked list, the traversal is not easy. Traversal means to visit each and every node at least once. So that is called as traversal. So in a linked list, the traversal is not easy. If we want to access the element in a linked list, we cannot access the element randomly, because we don't know where exactly that element is stored. So we cannot access the elements randomly. We have to travel them, or we have to traverse them sequentially. So that is a problem. Then reverse traversing is also a problem. If it is a doubly linked list, then in doubly linked list we are having two nodes for storing address. One is for previous and one is for next. So with the help of doubly linked list, we can do the traversing in reverse direction. But if it is a normal linked list or a singly linked list, so then it will be very difficult to reversely traverse the list. So these are the disadvantages which are associated with linked list. Now next is the types of linked list. So the first is singly linked list, then doubly linked list, then circular singly linked list, and circular doubly linked list. So first is the singly linked list. So it is a commonly used linked list in programs. If we are talking about the linked list, it means it is a singly linked list. Unless and until we write doubly, we write circular doubly linked list. Otherwise, it is normally the singly linked list. The singly linked list is a data structure that contains two parts. One is the data part, and the other one is the address part, which contains the address of the next or the successor node. The address part in a node is also known as a pointer. Suppose we have three nodes, and the addresses of these three nodes are 100, 200, and 300 respectively. The representation of three nodes as a linked list is shown in the figure. So here you can see that there are three different nodes having addresses 100, 200, and 300. The first node contains the address of the next node, that is 200. The second node contains the address of the last node, that is 300. And the third node contains the null value in its address part, as it does not point to any node. The pointer that holds the address of the initial node is known as a head pointer, because we have to start the linked list and we have to keep track of the first node. If we know from where the first node is getting started, we can traverse the list because every node is having address of next node. So that is the point. So we have to keep the track of the first node. Like we have to store the address of the first node somewhere. Like in this example, it is 100. So we had stored 100 in the head node. Head is pointing towards the first node. The first node is pointing towards the second. Second is pointing towards third, and third is pointing towards nothing, because after that there's no node in that. Now this linked list is known as singly linked list as it contains only a single link. In this list, only forward traversal is possible. Reverse traversal is not possible. We cannot traverse in the backward direction as it has only one link in the list. We can traverse, like we can visit first node 1, we can visit the second node number 2, we can read, we can visit the third node number 3, we can read, but we cannot backtrack, or we cannot come backwards from 3 to 2 to 1 because there's no direction for coming back. So that is the drawback. Now, representation of the node in a singly linked list. So again, we had discussed this. We have defined a user defined structure named node containing two members. The first one is a data of type integer, and the other one is the pointer next of the node type. Now, what are the various operations which can be performed on singly linked list? So the first operation is node creation. So what we had done is we had defined a node. In previous example also we had defined a node. Now how to create a node? So here you can see with the help of, excuse me please, with the help of malloc function, memory allocation function, we had given size of struct node. So that node we had defined previously, and now we are asking for memory allocation, and the address of that node is stored in ptr. The return value of malloc will be address of the node or address of the memory location, and that address will be stored in ptr. So in this way the node is created. Now the next operation is insertion. Now, the insertion into a singly linked list can be performed at different positions. Based on the position of the new node being inserted, the insertion is categorized into the following categories. So, we are having, it depends upon the node where we are exactly inserting that node. So, insertion at beginning, insertion at end of the list, and insertion after specified node. So, if we are doing insertion at beginning, it involves inserting any element at the front of the list. We just need to do a few link adjustments to make the new node as the head of the list. Now, if we are doing insertion at the end of the list, the new node can be inserted as the only node in the list, or it can be inserted as the last one. And the third is insertion after specified node. So it involves insertion after the specified node. We need to skip the desired number of nodes in order to reach the node after which the new node will be inserted. So first we have to reach there where we want to insert the node, and after that by manipulating the links we can insert the node. Now next is deletion. So the deletion of a node from a singly linked list can be performed again at different positions, that is at beginning, at the end of the list, or in between, or at a specified position. So deletion at beginning is possible, deletion at the end of the list is possible, and deletion after specified node. Next is traversing. So traversing means simply visiting each node of the list at least once in order to perform some specific operation on it. For example, if we want to display the data, we want to print the data which is available on the list. So we have to visit each and every node at least once, then only we can print the data. So that is called as traversing, visiting each and every node at least once from start position till end position. So start position is pointed, or the first node is pointed by head, and the last node is having null value in its address part. So that is the ending point of the list. The next operation is searching. So in searching, we match each element of the list with the given element. If the element is found on any of the location, then location of that element is returned, otherwise null is returned. So these are the various functions or operations we can perform on singly linked list, or the different, or on the different types of list. Now the important thing is the complexity, like how much time it is going to require. So there are two types of complexity: time complexity and space complexity. So space complexity, we are going to consider first space complexity. So it is O of n. Like if we are in need of n elements, so it is O of n. Now time complexity, here they had shown us in 2 points: average or worst. So there are four operations: accessing an element, searching an element, insertion, and deletion. So accessing an element, like we want to visit an element. So for that, visit a element. So for that, we have to traverse the list up till that location. So the complexity is, average complexity is theta of n. Similar is with searching also. So again, the average time complexity is theta of n. Whereas for insertion and deletion, the average time complexity is theta of 1. The worst case time complexity for access and search is O of n, and for insertion and deletion, it is O of 1. Next is the doubly linked list. Doubly linked list is a complex type of linked list in which a node contains a pointer to the previous as well as the next node in the sequence. So as compared to singly linked list, doubly linked list is a complex type of linked list because it is having two pointers. One is previous pointer and the next is the next pointer. Therefore, in a doubly linked list, a node consists of three parts: node data, pointer to the next node in the sequence, that is next pointer, and pointer to the previous node, that is previous pointer. So here, like up till now, whatever linked list we have seen, in a node we are having two parts. In doubly linked list, in a node we are having three parts. Here you can see. This is a sample node in a doubly linked list. So data part, previous part, and next part. The previous part of the first node and the next part of the last node always contain null, indicating end in each direction. In a singly linked list, we could traverse only in one direction because each node contains address of the next node and it doesn't have any record of its previous nodes. However, doubly linked list overcome this limitation of singly linked list due to the fact that each node of the list contains the address of its previous node. We can find all the details about the previous node as well by using the previous address stored inside the previous part of each node. So here, reverse traversing is also possible, or traversing in both the directions is possible. So here in this diagram, a doubly linked list contains three nodes having numbers 1, 2, 3 in their data part. So here you can see we can, from with the help of head, we can visit to first node, which is having data 1. Then we can move further, it is data 2. Then we can move further, it is 3. That is the last node. Now once we have reached the last node, now we can traverse in reverse direction also. We can access data as 3, 2, 1 because we are having pointers for previous nodes as well. But the main point is the previous part of the first node and the next part of the last node will always contain null. This is very important. Now in C, structure of a node in doubly linked list can be given as, this is similar to the node which we had declared in singly linked list. Only difference is, like here we have to declare one more pointer, that is previous. Apart from next, we have to declare one more pointer, that is previous. Now, memory representation of a doubly linked list. Now, how exactly in memory this doubly linked list is stored? So here we are having three parts in a node: data, previous, and next. And the memory allocation is random. You can see the first location is occupied, second and third location is free, fourth location is occupied, then sixth location, and then eighth location. So in this way, memory location is allocation is random. It is not sequential. Now the first data is stored in the location first location. So the head will have the value 1 and it is pointing to the first location. So the data is having 13, previous is having -1. This is basically null. So if we are going to store 0, so it will be confusing it with a number. If we want to denote null, here we can use -1 for denoting null. So here you can see first node's previous part and last node's next part both are having null pointers, that is -1. The next pointer is pointing towards the location 4. So there we are having the next node. Now previous to location 4, the node is stored at location 1. So in previous we can see 1 and in next node it is 6. At sixth location we are having another element. Then at eighth location we are having another element and so on. So this is the memory representation of a doubly linked list. Now again the operations on doubly linked list. So the first operation is node creation. So here again the node creation is similar to that as singly linked list. The difference is that here we have declared two pointers. Apart from that, the operations which are possible are insertion, deletion, traversing, and searching. These are similar as we had done in singly linked list. Here, instead of handling or manipulating one pointer, we have to manipulate two pointers. That is the only difference here. Now, next comes circular singly linked list. So, in a circular singly linked list, as the name of the linked list is circular, this means the last node of the list contains a pointer to the first node of the list. We can have circular singly linked list as well as circular doubly linked list. Started. For example, we have started from first location. We had traversed the whole list and now again back we'll be coming at first location only. The circular singly linked list has no beginning and no ending. There is no null value present in the next part of any of the nodes. This is very important that in circular singly linked list, there is no null value present in the next part of any of the nodes. This is the image which is showing us the circular singly linked list. Circular linked lists are mostly used in tasks maintenance in operating systems. There are many examples where circular linked lists are being used in computer science, including browsers. Like we always surf the pages whenever we are going to visit any site, we used to surf the pages. So if I want to go to the previous page, I'll simply press the previous button and I can go to the previous page. So this is the data structure which is used to store those pages. With the help of this we can access the pages easily. Like if I had reached to first node, then I'll go to second node. Now again if I want to go to first node, I can go back. Memory representation of circular linked list. Here you can see that the last node, here we are having only two parts. In doubly linked list we are having three parts. One is for data, one is for previous node, and one is for next node. But here in circular singly linked list we are having two parts in a node. One is data part and one is address part. In address part we are pointing towards the next location, but the last node will point to the first location. So here you can see at the 8th location, this is the last node. So again it is pointing to first location. So address of last node is address in last node is stored as 1, which is the address of first node. So this is the circular queue. Sorry, circular linked list. Now the operations which we can perform here. So first of all, creation of a node. So it is similar to singly linked list only. Only the difference is that in the last location, we have to store the address of the first location. That's it. That is the only difference. So that change we have to make it in program. Apart from that, creation of the node is similar as singly linked list. Then insertion at beginning, insertion at end of the list is possible. Deletion again at beginning and deletion at the end of the list is possible. Then traversing and searching is also possible here in circular linked list. Only thing is we have to take care of the first node, that again we are coming back to first node, so we have to take care of that. Next is circular doubly linked list. Now, circular doubly linked list is a more complex type of data structure in which a node contains pointers to its previous node as well as the next node. Circular doubly linked list doesn't contain null in any of the node. The last node of the list contains the address of the first node of the list. This is since this is circular. The first node of the list also contains address of the last node in its previous pointer. We can see this with the help of example. So here you can see this is the circular doubly linked list. So here you can see this last node will have address of first node, and this first node will have address of last node. In this way it will become circular. Since it is doubly linked list, so we'll have addresses of both the nodes in both direction. Now, a circular doubly linked list contains three parts in its structure. Therefore, it demands more space per node and more expensive basic operations as compared to singly linked list or circular singly linked list. Doubly linked list is more expensive because here we have to manipulate more links. Doubly linked list provides easy manipulation of the pointers, and the searching becomes twice as efficient because we can traverse in both the directions, forward as well as backward. Now in this figure, we can see how the memory is allocated for a circular doubly linked list. The variable head contains the address of the first element of the list, that is 1. The starting node of the list contains data A and it is stored at address 1. Since each node of the list is supposed to have three parts, therefore the starting node of the list contains address of the last node. So here you can see the last node is 8, address of the last node is 8, and address of the next node is 4. So that we have stored in the address part. The last node of the list, that is stored at address 8 and containing data as D, will have address of previous node. So previous to D is C and that is stored at location 6. So that's why it is 6. And the last node is again pointing towards, next pointer is again pointing towards the first node, that is 1. The last node is identified by the address of the first node, which is stored in the next part of the last node. Therefore, the node which contains the address of the first node is actually the last node of the list. So, how to identify last node in a circular doubly linked list? So, the node which is having address of first node in its next part is known as the last node of the doubly linked list. Now, the operations which are possible on doubly linked list is again insertion, deletion, traversing, and searching. Now, briefly, we had discussed the four different types of linked lists. Now, the next are the problems or the questions which are asked in the various years in GATE question paper. So the first question is, consider the below code which deletes a node from the beginning of a list. So the code is given to us. The code is for deleting a node from the beginning of a list. If it is a list, means a singly linked list. So this code is for deleting a node from the beginning of a node list. That is the first node. So we have to complete the code. So it is, the function is void delete front. If head is equals to null, return. This means there's no list available. So if this is the condition, then it's okay. Otherwise, we have to go to else part. Now in else part, what code we have to write? We have to delete first node. So we have to write code for deletion of first node. Which lines will correctly implement else part of above code? So if head of next is equals to null, head is equals to head of next. So what they are telling us, if head of next is equals to null, this means that this is the only node available there, but that is not the case. We have to consider a linked list. So here in the second option, if head is equals to tail, this means that only one node is available. Then head is equals to tail is equals to null. Else head is equals to head of next. This is the correct option, because what we are considering here, that if only one node is available there, then also we're having that thing that if only one node is available, if we'll delete it, head and tail both are going to point towards null. And if we are having more nodes in list, at that time deletion of first node is head is equals to head of next. With the help of this statement, shift we can directly shift the head pointer towards the second node. So the second option is correct. Next, when a new element is inserted in the middle of linked list, when a new element is inserted in the middle of singly linked list, then the references of dash to be adjusted or updated. References means addresses. If we are inserting a new element in the middle of a singly linked list, then we have to update or adjust which references. So the first option is those nodes that appear after the new node, those nodes that appear before the new node, head and tail nodes, and those nodes that appear just before and after the new node. So this option is correct. We are inserting an element in between. So we have to adjust the references of nodes which are just before and after the new node. We don't have to adjust the references of head and tail nodes. We have to adjust the references of the nodes just before and after the new node. Which of the following program segment correctly inserts an element at the front of the linked list? So here again, the code is given to us and we have to identify the correct code which is used for inserting an element at the front of the linked list. Assume that node represents linked list node structure, value is the element to be inserted. So the first option is temp is equals to node star malloc size of node, temp of data is equals to value, temp of next is equals to head, and head is equals to temp. No, this is not the correct option. Okay, temp is equals to node malloc size of node. Okay, I'm sorry. In the first node only, in temp only, we are having the address of the node. Okay. Now in the temp of data we had stored value. In temp of next we had stored head, and now head is pointing towards temp. Head is equals to temp. So the first option is the correct option. Linked list uses null pointer to signal end of list, start of list, either A or B, neither A nor B. So linked list uses, singly linked list uses null pointer to signal end of list. So the option A is correct. Now, linked list can be sorted by swapping data only or by swapping addresses only. So we have to swap both. We have to swap addresses as well as data. So the option C, that is both A and B, is the correct option. Now, insertion of node in a doubly linked list requires how many changes to previous and next pointers? The question is, insertion of node in a doubly linked list requires how many changes to previous and next pointers? So two next pointers are getting changed and two previous pointers are getting changed, because the node which we are inserting in between, we have to manipulate the pointers of that node, then we have to manipulate the pointer of previous node and manipulate the pointer of next node as well. So two next pointers and two previous pointers are getting manipulated. So the option is B. Now, which is true about linked list? A linked list is a dynamic data structure. A linked list is a static structure. No, this statement is not correct. A stack cannot be implemented by a linear linked list. This is also not correct, because stack can be implemented using linear linked list. None of the above is also not the correct option. So correct option is a linked list is a dynamic data structure. In a circular linked list, insertion of a record involves the modification of. In a circular linked list, insertion of a record involves the modification of. The correct option is two pointers, because where we are inserting the node. So if it is in the first position, then we have to manipulate two pointers, the head pointer as well as the next pointer of that new node. Similarly, अगर आप last location पर new node insert करते हो, then again you have to manipulate two pointers. So whenever we are, or if in between we are adding some node, we have to manipulate two pointers. So in a circular list, wherever we want to insert a record, it involves the modification of two pointers. The following C function takes a single linked list of integers as a parameter and rearranges the elements of the list. The function is called with the list containing the integers 1, 2, 3, 4, 5, 6, 7 in the given order. What will be the contents of the list after the function completes execution? So the question is, one function is given to us, C function is given to us. In that function, rearrange function is there, which rearranges the list which is already provided. So the function is called with the list containing the integers 1, 2, 3, 4, 5, 6, 7 in this sequence only. Now after giving this list as input, what will be the output? So first of all, we had declared the node part, then the function void rearrange. Now here we had declared two pointer variables, one is p, one is q, one normal temporary variable. Now the first condition is if not list or not list of next, then return. Not list means if list doesn't exist, if there's null in the list, or if this is the last node, if this is the only node in the list, then return. This means that arrangement is not possible. Then p is equals to list. P pointer is pointing towards the list. Q is equals to list of next. Q is pointing to the second node. So P is pointing to the first node. This means P is pointing to 1 and Q is pointing to 2. Because in the list, the data which is stored is 1, 2, 3, 4, 5, 6, 7 in this sequence only. So P is pointing at 1 and Q is pointing at 2. While Q is not equals to null, execute the while loop. If the condition is true, then execute the while loop. So q is not equals to null. So temp is equals to p of value, p of value is equals to q of value, and q of value is equals to temp. This means what? We are exchanging the value of p and q. So P is pointing to 1 and Q is pointing to 2. So with the help of temp variable, a temporary variable, we are exchanging or we are swapping the values of 1 and 2. So now 2 will be at the location of 1 and 1 will be at the location of 2. तो अब हमारा sequence हो जाएगा 2 1. So previously the list is 1 2. After executing the while loop, now the sequence is 2 1. Now after this, P is equals to Q of next. This means P is pointing to 3 and Q is equals to P of next. Q is pointing to 4. Previously, P was pointing to 1 and Q was pointing to 2, और 1 और 2 जो है वो स्वैप हो गए. अब वो हो गया 2 and 1. अब P जो है वो 3 पर पॉइंट कर रहा है और Q जो है वो 4 पे पॉइंट कर रहा है, तो ये दोनों भी स्वैप हो जाएंगे. सो नाउ इट विल बिकम 4 3. तो अब सीक्वेंस हो जाएगा 2 1 4 3. नाउ P will point to 5 and Q will point to 6. Again swapping hoga, so now the sequence will become 6 7. So it is 2 1 4 3 6 5. Now 7 and now we don't have any element. So Q में जो है Q of next जब हम डालेंगे तो Q में null आ जाएगा. Null जैसे ही आ जाएगा हम while loop से बाहर आ जाएंगे. Now after this the result is, so the correct answer is option B. It is 2 1 4 3 6 5 7. So ये code basically ये कर रहा है कि जो first two elements है उनको swap कर रहा है, फिर जो next two elements है उनको swap कर रहा है, and so on. So now the correct sequence is 2 1 4 3 6 5 7. That is option B. What is the worst case time complexity of inserting n elements into an empty linked list? The question is, what is the worst case time complexity of inserting n elements into an empty linked list if the linked list needs to be maintained in sorted order? So we have to insert the data as well as we have to sort it. So it is n log n. So the correct option is C, that is theta of n log n, because we have to insert data as well as we have to sort that data. So sorting and insertion, both the things are there. So the complexity is theta of n log n. Now with regard to linked list, which of the following statement is false? An algorithm to search for an element in a singly linked list requires O of n operations in the worst case. This is true. An algorithm to search for an element in a singly linked list requires O of n operations in the worst case. Because if there are n elements in the list and we have to search any element, so we have to perform O of n operations. So this statement is true, but we have to find out false statement. An algorithm for deleting the first element in a singly linked list requires O of n operations in the worst case. Whereas for deletion and insertion we have seen complexity, so it is worst case complexity is O of 1. So this statement is not correct. So the correct option is option B. In a circular linked list, components are all linked together in some sequential manner. There is no beginning and no end. Components are arranged hierarchically. Forward and backward traversal within the list is permitted. So components are arranged hierarchically. This is not correct. Forward and backward traversal within the list is permitted. This is also not correct. There is no beginning and no end. This option is correct because in circular linked list, we don't have beginning and end nodes. A linear collection of data elements where the linear node is given by the means of pointer is called linked list. A linear collection of data elements where the linear node is given by the means of pointer is called linked list. So the correct option is A. Given two statements, we have to tell which statement is true and which statement is false. Insertion of an element should be done at the last node in a circular queue, and deletion of an element should be done at the last node of the circular queue. No. Insertion is possible at the first node or in between, as well as deletion is also possible at the first node or in between with last. So both the statements are false. In a linked list with n nodes, the time taken to insert an element after an element is pointed by some pointer is, this means what? We have to perform insertion operation, and already where we have to insert, we had reached to that location. Simply we have to perform insertion operation. So only one operation will be there. So the complexity is O of 1. If we don't know the location of the node where we have to insert, then the complexity will be O of n. But right now we know where exactly we have to insert the element. So the complexity will be O of 1. So the correct option is A. In the worst case, the number of comparisons needed to search a linked list of length n for a given element is, in the worst case, we have to search all the elements. Size of the list is n, so comparison will be of n times. So the correct option is D, that is n. In worst case, in best case, it may happen that the element which we are searching, we will get that element at first location. But in worst case, the situation is that we'll get that element at the last location, or after searching whole list we won't get the element. So the number of comparisons which we have to do is n. So the correct option is D. Let P be a singly linked list. Let Q be the pointer to an intermediate node X in the list. What is the worst case time complexity of the best known algorithm to delete the node X from the list? So it is O of 1. Again the same thing. इसके पहले ये क्वेश्चन इंसर्शन के लिए पूछा गया था, सेम क्वेश्चन डिलीशन के लिए पूछा गया है. If we have to traverse up till there and then we have to do the deletion operation, then the complexity will be O of n. But we already know where exactly we have to delete the element, or which node we have to delete. So that will take O of 1 time only. So the correct option is option D. Linked lists are not suitable data structures of which one of the following problems? Like for insertion sort, we can use linked list. For binary search, they are saying that for binary search, linked list is not the suitable data structure. So the answer is given to us as binary search. For radix sort, for polynomial manipulation, so application of linked list is polynomial. It is used for solving polynomial expressions. So that is not the case. So out of searching or sorting, binary search it is not at all suitable. That's it. This much is there in today's lecture. These are the problems which have been asked in GATE on the topic linked list. Now in next lecture we'll study trees. So there are different types of trees. So we'll first discuss the different types of trees, and then we'll see the problems which are asked on trees. So in next lecture we'll start that. Thank you all.